Hi, and welcome to S for Science. And can we travel to the center of the Earth? The writer Jules Verne already asked himself this question when he made Journey to the Center of the Earth. In this book, he told the story of three protagonists who descend a volcano, reaching a kind of ocean that was under the Earth that also contained a lot of air. In this ocean, they went through a lot of adventures, encountering dinosaurs and even men. Later, when they were already very close to the supposed center of the Earth, a volcanic eruption returned them to the Earth's surface in such a way that they missed the center of the Earth, but barely. This is obviously a fantastic novel, since there are no such large expanses of air below the Earth's surface. But nonetheless, Jules Verne was not entirely wrong. Relatively recently, a special diamond was discovered in Brazil. This diamond that had risen to the surface by a volcano from a depth of about 600 kilometers contained a mineral that until now had only been observed in meteorites. And it's very special because it contains a lot of water inside. This made scientists think how a mineral that came from 600 kilometers of depth could have such a high concentration of water. So now there's a hypothesis that under our feet, in the Earth's mantle, there's an ocean of colossal dimensions. In a certain way, Jules Verne was not wrong. But how deep have humans reached? This is the Kola well located in Russia. And with 12,262 meters of depth, it's the deepest place that has ever been reached. In 1992, they suspended the excavations because the temperatures reached 182 degrees in the drilling areas, given the high temperatures that are achieved by digging very deep. Currently, the well is abandoned since it's no longer possible to work with today's technology. But were they near or far from the center of the Earth? Our planet has a radius of 6,371 kilometers, while the excavation only reached 12 kilometers. It would be as if we took an apple to represent our planet and made a scratch like this. This would be the perforation that they did in Russia. Not much, honestly. They didn't even manage to cross the terrestrial crust. That would be basically the skin of the apple. However, they discovered very interesting things. One of them was the discovery of large amounts of water that came from the depths. This is related to the diamond discovery they made recently in Brazil. Another interesting discovery was the high concentrations of hydrogen they detected in the rocks. Hydrogen is a gas that was not believed to exist natively on Earth. However, it was discovered that it exists in the depths of the Earth. And this helped to understand a lot better how our planet formed. But what would have happened if they had continued to drill, assuming they could? The little we know about our planet's interior and its structure, it's based on indirect measurements. Indirect measurements are those that do not really show directly how something is, so we have to deduce it from its position. The indirect measurement that is most used in geology in the studies of the interior of the Earth is that of seismic waves. Now, you're seeing a very simple diagram in which the speed and the depth of the waves are shown. There are two types of waves, P waves and S waves, primary and secondary waves respectively. One characteristic of the S waves is that they do not go through fluids. However, all waves go slower when they go through fluids. As you can see, below 3,000 kilometers deep, S waves can no longer pass, which suggests that at that point there is a radical change of the physical state of the materials that go from solids to liquids. Later we will see what that is. Also, an increase of the speed is observed before reaching the depth of 2,000 kilometers. This is basically due to an increase of the density, since the heavier rocks are found more to the bottom of the Earth. With this information and the help of others, scientists have managed to get an idea of what is under our feet. So what would have happened in the excavation of Russia, assuming that we had a machine that could sustain heat better? So approximately 60 kilometers deep, we would find a partially molten rock. It would be solid, but it would have a behavior similar to clay. It could be molded in a certain way. At 650 kilometers deep, we would find the lower mantle. a layer with a plasticity much lower to the superior mantle, that is, harder. If we could continue going down despite the extreme temperatures, we would reach approximately 2,800 kilometers in an ocean of molten iron and nickel. This is the outer core, that is at the incredible temperature of 5,000 degrees, which is the same as the surface of the Sun, and approximately at 5,155 kilometers deep, we would come across a solid and rigid sphere of nickel and iron. This is the inner core, and it is at the extreme temperature of 5,400 degrees. Here, the question that arises is why the core of the Earth, despite being hotter than the outer core, is totally solid? This occurs due to a law already defined by thermodynamics that postulates that a substance can remain in a solid state if the pressure that is exerted on it is very high. In the case that we're studying, the core of the Earth, the pressure is 360 gigapascals, or to give you an idea, 3,600,000 times the atmospheric pressure. And it's this extremely high pressure that makes iron, despite being well above its melting point, remain solid. It's the same effect that has been produced in laboratories, where they have managed to maintain ice at a temperature of 20 degrees without melting, simply by increasing the pressure. These high pressure and temperature conditions make it very difficult to imagine that a human being can survive in these conditions. And in the same way, it is practically impossible that any of the machines or instruments that the human being have been able to develop at the moment can exist in such conditions. So for now, reaching the center of the Earth is impossible. For now. Thank you very much for watching this video, and goodbye.